Okay, here we go. This is read the integral from a to b of f of x dx. This symbol right here is an infinite sum symbol. Combine this infinite sum symbol with this f of x and this dx, you're taking an infinite sum of heights times infinitely skinny widths, and you get exact area. Okay? What we'll find is that this symbol, skinny s, has another meaning depending on what you see next to it and what's there or not there. So it can get confusing, which is why we want to make sure I will mention this frequently. Okay? But it's read the integral from a to b of f of x dx. Notice a to b is very specific. Order is going to matter where this a and b is going to be placed. Order matters. Okay? In the integral, the bottom number is where you're going to start, is what we'll try to say, your infinite sum. And the top is where you're going to end. Okay? Because an infinite sum from, say, 1 to 3 of some function, that's going to be different than an infinite sum from 3 to 1. And we'll see what the difference is in a little bit. Before, we're going to kind of review what we talked about towards last class, what our areas are going to be, positive or negative, depending on where our function is. And kind of explain how we're going from A to B, why that matters in terms of order. Okay, so if I took an infinite sum of infinitely skinny rectangles, here's an example of one of the rectangles. Okay, we know in this situation with the function being above the x-axis that this function value is going to be positive. Well, here's where the direction matters. Going from A to B, here from A to B, I'm going from left to right. Well, on the x-axis from left to right, that is in the positive direction. We would say these widths are positive. So if I'm finding this area, you would say, okay, positive heights, positive widths, area is positive. Which is why when the function is below the x-axis, like here, if I took a rectangle, as an example of a rectangle, my function values, which are my heights, would be negative, but since I'm going from left to right, my widths are still positive, and all of a sudden I have a positive times a negative, which is why we say the area is negative. Sorry, negative times a positive. It could be a negative. Negative heights, positive widths. Okay, well, let's go opposite. Instead of going from like A to B or like 1 to 3, let's go from 3 to 1 or B to A. Okay? Let's see what happens when I draw one of my rectangles. Well, here, since it's above the x-axis, function value is still positive. But I'm traveling and taking an infinite sum starting at B and traveling to A. That is going in the left direction, which means my delta x is actually going to be negative. My dx, not my delta x, my widths. So all of a sudden, from B to A, or if you consider this 3 to 1, this area is now negative. Positive times a negative. And let's see what happens if I'm below the x-axis going from B to A. My function values are negative. That will be used for my heights. But since I'm traveling from B to A, my dx is also negative. All of a sudden, this becomes positive. So, 1 to 3 compared to 3 to 1, they're not the same, right? But what are they going to be? Not reciprocals. That's when you have 1 over. Not inverses. It's an O word. Opposites. The integral from B to A is equal to the opposite of the integral from A to B. This is the first property that you need to be aware of that you will use for certain questions. And all we're doing is different properties, and then we're going to do some example problems. You guys will get to practice. Okay, that's the first one. Second one, it's a fairly simple property if you think about it. The integral from A to A. The example would be like the integral from 2 to 2 of some function. Well, if I say here's A and it's at 2, and instead of having B somewhere else, I have B right here at 2, so I'm going really from A to A, what would be my area? Watch. We have area there, getting smaller, smaller, smaller. What would be that area if I have just one spot and ending at the same spot? 0. Thank you. Okay. Next property. That's the next property that you need to know. The next one. If I'm multiplying a function by a constant, here's a visual example that we will be able to do, and we'll be able to figure out what our property is in general. So I have a function, and I have 3 times the function. I took all the function values and multiplied them by 3. Let's compare the areas under both of them. So let's first find the area under just f of x from 1 to 3. We'll go from left to right in this case. Okay, we have just a triangle worth of area. The base length is 2. The height is 2. 1/2, 2 times 2 is just 2. Okay, so good start. Now let's see what the area of 3 times the function is. So we took all the function values, multiplied them by 3. Instead of going from 0 to 2, we now go from 0 to 6. Well, this area here in red is also a triangle. It'd be 1/2 my base length, since I'm going from 1 to 3, which is 2 times my height, which is 6, and that would just be 6. Okay? Well, notice the area for my first guy, 2. The area from 3 times f of x is 6. What can we say? Well, we can say that you could just take the area under f normally and just multiply it by the constant. This here is the same as if I take this 3 out and find the area. Here's that next property. Okay. We'll come back to that one. Here's the next one that's fairly intuitive, easy to understand. I have the integral from a to b of f of x dx plus the integral from b to c of f of x dx. Well, if I take this area here from a to b and add this area here from b to c, I get the area from what to what? A to c. Exactly. I can say this is just equal to the area or the integral from a to c.
Are you going backwards on the EDP one?
Nope. A to b, b to c. Okay. Next one, if I have a composition or a summation of two or more functions, let's say the integral from a to b of f of x plus g of x, or plus or minus g of x, all in parentheses multiplied by widths of dx. We'll find in the future that the parentheses won't always be there. We'll just assume that they're there. They should be there because we have heights times width. Infinite sum of heights times that consistent width. Okay, well, this is actually easy. More difficult to kind of show and explain, but turns out it's not that difficult to explain. Turns out if you want to find the area of f plus g, you could split this up into two different integrals. Just the area of f plus or minus the area of g. The next one, if I want to find the area or the integral from a to b under just a constant, let's see what that'll be. Let me show you an example and we'll be able to kind of go from our example to in general. Let's take the area or the integral from 1 to 4 of 5 dx. What will that equal? Well, this is the function 5. You don't have to have f of x in here. You could have, functions, versions of x squared plus 3x. You could just have a number like 5. All it is just the height that you are going to use. Here we're saying the height is going to be 5 everywhere. Well, I can draw the function y equals 5. Here is the function 5, right? Just a horizontal line passing through y equals 5. Well, I want to find the area under 5 from 1 to 4. What do I have? Just a rectangle. The area here would be the height of 5 times this width, which would be from 1 to 4, which is 3. That gives me 15. Well, you can do that for any constant, from any value to another value. It's just going to be your constant height, whether it's positive or negative, times the x distance from A to B, which you can find by just subtracting A from B. Okay? Now, combining this one and this one, we go to this guy. The integral from a to b of a function plus a number. Well, you can first split them up. You can find this and we know what this will equal. In the future, what you could do is just go straight from here to there and just say it's the area under F plus this height times this distance. In this situation, if we want to find the integral from 1 to 3 under f of x plus 3, and let's say we know that this area here is 4. Let's go from 1 to 3 of f of x plus 3. You can say, oh, that's just going to be 4 plus this extra area of 6, giving me 10. That's not 4. That's 1. 3. This should be 3. Width of 2, this would be 1/2 my consistent width, which is 2. 1 plus 2, that should be 3. So 3 plus 6 is 9. Okay. Cool. We are ready to do some examples. Now, for these examples and the problems you're going to see on your homework and the problems you're going to see for your next quiz, they're fairly straightforward. You're going to be given information, either a graph or certain integral notation expressions, equations really. You're given that, okay? You will use only that information to answer all 6 of these questions. Okay? You will be able to answer all the questions just with that information, and maybe with the information that you get from answering other questions, okay? For example, the one on the top left, the integral from 5 to 0. Well, I know the integral from 0 to 5 is 10. This is going to be the opposite, negative 10. Okay, that's it. You guys do the rest. The challenge one is the one on the bottom right. Let's see if you guys can get the one on the bottom right after you get the other ones. Once you're done, check your answers with the neighbor, and we will confirm them together. Okay, check your answers with a neighbor. Did you get the last one right? Did you get it? Good. Very good.
Yeah.
What'd you get?
I think it is one.
Yep.
I got one because that was that'd be one. Yeah, you flip it. Is that right?
Yep. Good. You guys are good. You guys are much better than the other classes. Good. You got 7 for the last one? Try it again.
1.
It is 1.
Whatever number is
Yep.
When you do the integral, is that what it's called?
Yep, it's an integral.
Of the 5.75 to -2, how do you get making that a regular 2?
Turn it into a regular 2, or you could keep it as a -2. It's just a height of -2, a width of 2, or a height of -2, width of -2. So that's why it's 4. And then f of x would be the opposite, -3.
It's just 3 times 5 is a rectangle.
Okay, here we go. First one, we should have gotten simply the opposite of 10, -10. Second one should be easy. It's just 0. From 0 to 7, we just add 0 to 5 and 5 to 7. That's the whole a plus b, b plus c. 10 plus 3 is 13. Third one, we got -3 times f. The constant just can be multiplied by the value, and you get your answer, -9. This one, what I like to do, if you are struggling, is to split them up and do them step by step. I know you don't want to do it that way, but if you want to make sure you get the right answer, maybe do it step by step. You split them up, then you say, okay, from 0 to 5, that's 10. And then from 0 to 5 of 3, that's the height of 3, the width of 5. You have, answer just disappeared. There it is. You have the 10 plus the 15, giving you 25. The last one. There are many ways to do it. You might think your way is easier than mine. This is how I would do it to make sure I got the right answer. I start by saying, okay, from 7 to 5, let's change it to 5 to 7 and say it's the opposite of the integral from 5 to 7. I'm just going to work with 5 to 7 and then change them. I then can split them up. Again, it's going to be the opposite of just 5 to 7 of f minus the integral from 5 to 7 of 2. We know what 5 to 7 of f is. It's 3. Height of 2, width of 2, that's going to be 4. 3 minus 4 is -1. Take the opposite of it as 1. Could you have done it without writing all that stuff out? Sure you could have. If you got it wrong, maybe try this way. Okay. Next one. The one on the left is easy. The one on the right is another kind of more difficult one. Just like the last one, let's see if we can get that one on the right as the challenge. You guys did well on the previous. Okay, check your answers. Here's the long way. Just immediately say I'm going to take the opposite of my answer from 2 to 6. Split them up. Pull out the -2. I have negative. G of x is -2. Minus 2 times f of x would be -20. -2 minus 20 is -22, but take the opposite of that. The answer is 22. How do we do? Thumbs up, thumbs down. All right. Some decide to abstain. That's okay. All right, here's a real challenge. Do these two. I didn't make it a super duper challenge because I made you do the first one. I could have just made it super hard or super tricky maybe. It's not super tricky, but trickier if I just gave you this problem. But I'll tell you right now, do this one and then do that one. Go. Check your answer with a neighbor. Maybe you're struggling. Maybe you don't know where to start. Okay. First one you got to figure out by manipulating this given up here. You got to figure out that the integral from 0 to 5 of f is just 2. How do you do that? You can just pull out the 3, divide both sides by 3. Okay. So that gives you that the integral from 0 to 5 of f minus g is 2 minus 7, which is negative 5. You need that answer to be able to get this answer. How will we get this answer? Well, it's the whole a to b plus b to c equals a to c. If you have a to c, 7, and you have b to c, you can just subtract the b to c from the a to c, and you'll get the a to b. So negative 5 minus 2 gives you the answer negative 7. Okay? All right, this picture should look familiar. Let's finish off class by doing these three. Zero to 5. This is 3. This is 4. This is 1. This is negative 2. So opposite of the area from 0 to 5 of negative 3 f of x dx, or it would be positive 3 area from 0 to 5 of f of x. 4, 5, 6, 7, 8 times 3 is positive 24. This is 0. This one would be the area from 5 to 7. The opposite of the area from 5 to 7 of f of x plus the area from 5 to 7 of 3. This ends up being negative 2 plus 6. The opposite of that would be negative 4. Okay, kind of tricky. Do your homework. It's not very long. It's probably the last short homework we'll have for this unit and next unit. Thank you.